Hello friends, welcome to Software Testing Guide. Today I am going to explain you software development lifecycle using V model for the automotive software. First I will explain what is the software development lifecycle. Actually software development lifecycle is the process used by the software industry to design, develop and test the high quality software. So let's get started. We will see the steps and procedure which are followed in automotive software. So what is V model? Just unlike an waterfall model, agile model, life cycle of V model is sequential path of execution process. So it is similar to waterfall, agile and life cycle of V model. Then each phase must be completed before begin of the next phase. So in this model, same like waterfall, before start of the next phase, first phase should have been completed. The testing of the product is planned in parallel with corresponding development phase. For each development phase, there is corresponding testing phase. We are going to see that in coming slides. This is the actual picture of V model. Here you can see the various steps in which are followed in V model. First, it will start from the requirement gathering. For requirement gathering, parallel it is associated. The testing side is acceptance testing. Then next phase comes system analysis. For system analysis, there is system testing. For software design, there is integration testing. For model design, there is unit testing and coding. So first part is requirement gathering. As we are going for the automotive software example, so I will explain how it will be in automotive software. So let's take an example of seatbelt issue. Usually in automotive industry, software is developed for the issue, that is electronic control unit. There are various issues and there is one main ECU which controls the various ECU in vehicle. So let's take an example of one requirement, that is seat belt ECU. See ID 001, ID 002, ID 003, ID 004 are these are the requirements. Let's take an first example. Check if seat belt worn or not. If seat belt is not worn, then indicate alert in cluster. If seat belt is not worn and vehicle speed is greater than 20 km per hour, then start the chain. So this is the first basic requirement about the seat belt. And next requirement is that fasten the tensure when emergency brake is applied. Suppose the vehicle is running with the more than average speed, and at same time if we press the emergency brake, then what should happen? At that time tension should get fastened. So this is the ID 002 says. And what says ID 003? When crash is detected, lock the seat belt. Whenever vehicle detects the crash, then it should lock the seat belt automatically. That is the ID 003 intention. And next requirement ID is ID 004. What that ID says, after crash is detected, check the speed, and if the speed is equal to 0, then unlock the seat belt. Suppose crash is detected and after crash detection, if the speed is 0, then it should unlock the seat belt, because the any emergency happened at that time. After crash is detected, persons or passengers within the vehicle, they should get outside. So it is possible only if the seat belt is unlocked. So this is the basic requirement for which we will see the entire V model. Okay. Next, system analysis. Once you gather the requirement, then next part comes the system analysis. What will be the hardware? What will be the processor? What will be the software? What are the input, signal, output load, sensor, actuators, and how entire system will work? That all part comes under the system analysis. So system analysis is the clear picture of the exact system, how it will work and how it will perform. That's it. So this part comes under system analysis. So first part we covered the requirement gathering, then we reached to the system analysis, and after system analysis, what is the next process? We will see. That is the software design. Under this part, the concerned team of the industry, automotive industry, maybe it may be the own R&D unit, or maybe it is the third-party consultant which provide the service for the OEM. Usually they perform this kind of the process and stages of the V model. So in this stage, application software design including the software submodules, combination modules, IO modules, diagnostic modules, and OS integration. Software, how it is prepared? It is prepared by using various subcomponents of the software, which includes the integration with hardware, what will be the operating system, what are the communication intermodules, what are the IO modules. These all part comes together and software becomes. That is the highlight of the software design. So next part is the module design. Under software, there are various modules, function wise or maybe component wise. For requirement which we have seen, for that maybe seat belt indicator, cluster set, that will be the one module, software module. Seat belt lock unlock, that will be the separate module. So these are the various modules which are required for to design to develop the software. Next part comes coding. Once you have defined the models, then actual coding part starts here. So for that, we need to create the algorithms, state machines, and C coding will get started in this phase. Then for this coding part, unit testing will be performed, and this will be performed by the usually it is performed by the developers who develop the software, who do the coding of that particular software. And for that, it is we call as module level testing. The next part comes integration testing. It is associated with the software design. Okay. In this testing of different software models together to check the functionality, software and integration test as well. Once various modules are designed and developed, at that time testing required, that testing is called as integration testing. Integration of one module with another module is called as integration testing. And after integration testing, next part called system testing. In system testing, exact software will be checked here, entire software including the modules. So how ECU is working along with the whole hardware software in actual environment. In the system testing, whole system is going to be tested, where all modules will be present, all hardware will be present, whether they can be simulated or real. In this type of testing, usually it is performed by the hardware in loop testing or software in loop testing. So in this testing, in hardware loop testing, actual hardware, that means sensors, then actuators, loads, and another supporting loads that will be present with the system. Might be they are simulated or real, but they will be present with the ECU. So SIL testing also can be performed at this level, software in loop without any keeping the hardware in loop. So this is the system testing which is associated with the software design and system analysis. Then next part, which is the last stage of the V model, that is the acceptance testing. In this level of testing, whole system is testing in the real environment. Suppose your ECU vehicle complete software development is completed and you want to test it, then at this level it is tested on the real time system. That means real